This delicate transport operation is taking the mirror of a high-resolution telescope to a new observatory in the mountains of Arizona. Here on Mount Graham is where the instrument called the Large Binocular Telescope, or LBT, will take its first look at the sky. The new super eye will afford astronomers a glimpse of faraway worlds. Two giant mirrors more than 8 meters across gather the light coming from space. Placed on a common mount, the mirrors can be adjusted to point like a pair of binoculars at distant targets. In a laboratory in Heidelberg, researchers from the Max Planck Institute are testing components they've designed especially for the LBT. Their optical device, known as the Link Nirvana Beam Combiner, will increase the resolution of the telescope enormously by superimposing the beams of light collected by the two mirrors.
Using the LBT, we'll be able to register the light from a candle located at a distance of 2 million kilometers. That's 6 times further than the moon.
Martin Koerster's team will be using the telescope's sharp eyes to investigate young stars, which are surrounded by a disk of gas and dust, a feature which is believed to be the birthplace of planets. The scientists hope their hunt for distant planetary systems will help in our understanding of the formation of our own solar system. By merging the beams of light reaching the two mirrors, the astronomers hope to obtain images of any planets which may be orbiting the stars.
What happens when the two beams are combined is that the light will either be enhanced or it will cancel out. The trick is to ensure that within our observational field, light is cancelled out at certain points and augmented at others.
In this case, the astronomers want to eliminate the interfering glow of stars from their observations, allowing them to focus on the darker planets, which do not themselves emit light. The Max Planck Institute for Extraterrestrial Physics, just outside Munich, is also working on the Large Binocular Telescope. Its near-infrared camera and spectrograph, known as Lucifer, can help astronomers analyze the light coming from distant galaxies. American astrophysicist Matthew Leonard wants to use the instrument to catch glimpses of the universe's distant past. The accepted Big Bang theory says, after the huge initial release of energy in the early universe, the gas began to cool, making the universe opaque. After some time, the first stars began to form out of the gas and began to emit light. The opaque veil was lifted, and thus astrophysicists are able to use the LBT to see stars and early galaxies. Leonard wants to find out how galaxies developed, which means he must examine these early galaxies in detail. Each image of a galaxy is only a snapshot of its individual stage of evolution in billions of years of development.
One of the mysteries is that, how do galaxies form? How did the stars in the galaxies get there in the first place? And while it's true that you could use nearby galaxies to help you understand some of these things, I think the importance of studying the most distant objects is that you can just see what the physical processes were directly that happened in these early galaxies.
The Large Binocular Telescope, due to go into service in October this year, will open a new window into the depths of space and the history of our universe.